Hey everyone, and welcome to this explainer. I am so incredibly excited to have you here today because, honestly, we're looking at a piece of research that represents a massive, game-changing leap in the world of artificial intelligence. We're unpacking the brand new VibeVoice technical report, which was recently published by a team of researchers on Archive. If you've been following AI speech generation at all, you know we've made some huge strides lately, but there's always been this fundamental roadblock when it comes to long, multi-speaker conversations. It just gets too heavy. Well, this paper introduces a novel model designed specifically to shatter that roadblock. We're going to walk through the exact architecture, the data, and the specific technological breakthroughs that make this all possible.
I want to immediately hook you with this staggering number, 90. Up until very recently, generating high-quality AI speech was, measured in seconds. Maybe a minute or two if you were really pushing the system to its absolute limits before it just started to hallucinate or completely break down. But the headline breakthrough from the VibeVoice paper is that this new model can synthesize up to 90 minutes of continuous, coherent speech, literally an hour and a half. That's the length of a feature film, an entire college lecture, generated continuously by an AI without losing its train of thought or dropping the audio quality. Absolutely wild, right?
So, which naturally brings us to the biggest question we can possibly ask. How can AI talk seamlessly for so long? Generating text is one thing, but audio? Audio is incredibly heavy data. Think about all the tiny nuances in human speech, the pitch, the breath, the natural cadence. Trying to calculate and generate all of that data continuously for 90 minutes would normally just crash the system entirely, or at best result in this robotic, lagging mess. To actually pull this off, the researchers had to completely rethink how the AI processes and compresses audio data. We're going to take a structured journey right now, completely under the hood of this technology, to see exactly how they pulled this off.
Okay, let's dive into this. Section 1. Under the hood, introducing VibeVoice and its unified method for modeling continuous data. To solve the massive problem of long-form speech featuring multiple interacting voices, the researchers developed what they call next token diffusion. Now I know this definition looks a bit dense, a unified method for modeling continuous data by autoregressively generating latent vectors via diffusion. Right. Sounds like a mouthful. But stick with me, because as someone who loves figuring out how things work, you're going to love how elegant this is when we break it down. Unlike text, which is discrete, one letter or word at a time, audio is continuous, it flows. Next token diffusion is basically a way to handle that flowing data. The autoregressively part, that just means the AI predicts the next piece of the audio sequence based on the pieces that came right before it, and it generates these pieces as latent vectors. Think of those as highly compressed mathematical representations of sound, using a diffusion process to refine them into clear audio. Let's move to and see how this builds across a clear three-step generation workflow. First step, step 1, the system models the continuous data. This means it preps itself to handle fluid sound waves instead of rigid blocks of text. Then, step 2, it autoregressively generates latent vectors. So picture the AI predicting the mathematical blueprints of the very next split second of sound based on what was just said. Finally, step 3, it synthesizes the actual speech via diffusion. Diffusion is this amazing technique where the model essentially starts with pure static or noise and mathematically sculpts it step by step until it perfectly matches that blueprint, resulting in crystal clear audio.
But here's the catch. Even with next token diffusion, doing this for 90 minutes is a computational nightmare. That brings us to section 2, the real star of the show, the secret weapon, a novel continuous speech tokenizer.
To really understand why this is a secret weapon, you gotta know that a tokenizer is the part of the AI that basically chops data into manageable pieces or tokens. If your tokens are too big or too complex, the AI gets completely bogged down when trying to process long audio sequences. Now, what's really interesting about this slide is the sheer scale of the improvement. The researchers put their new VibeVoice tokenizer up against the popular Encodec model, which is a widely used baseline for audio data compression. The VibeVoice tokenizer achieves an 80 times data compression improvement, 80 times. I mean, that isn't just a marginal upgrade, it is an absolute paradigm shift. By compressing the audio data 80 times more effectively, they free up a massive amount of computational power, which is exactly why the AI can suddenly generate audio for an hour and a half without crashing.
So the really crucial point to grasp here is understanding the trade-off, or actually, scratch that, the complete lack of one. Usually in computer science, if you compress data by 80 times, you're going to lose quality. Your audio ends up sounding like it's coming through a tin can on a string, right? But as this highlights, the VibeVoice tokenizer achieves this extreme computational efficiency for long sequences while perfectly preserving audio fidelity. It maintains comparable performance to the Encodec model baseline in terms of how good it sounds, but it requires a mere fraction of the data load to do it. It is literally the holy grail of audio processing. Way smaller size, same high quality. And because the audio fidelity is perfectly preserved, while the processing power is freed up, the AI can actually focus on the nuances. I absolutely love this quote directly from the abstract of the report. The researchers state that the model succeeds in capturing the authentic conversational vibe. You know, it's pretty rare to see a word like vibe in a highly technical AI research paper, but it really hit the nail on the head. Because they've completely solved the data compression problem, the model doesn't just read text out loud like a robot. It captures the unquantifiable human elements, the pacing, the natural overlaps, the intonation. It genuinely captures the actual feeling, the vibe of a real human conversation.
Let's pull all of these deep technical details back together into what this actually means for real-world capabilities. Here is the final scorecard for VibeVoice. It can generate up to 90 minutes of speech. It does this operating within a massive 64K context window length, which allows it to actually remember and reference things said an hour earlier in the generation. It can handle a maximum of 4 concurrent speakers, perfectly balancing their unique voices and that conversational vibe. And finally, according to the researchers, thanks to this unified next token diffusion and the novel tokenizer, it successfully surpasses both open source and proprietary dialogue models that are currently available.
Which leaves us with a truly fascinating and maybe slightly daunting reality to consider. We've just seen exactly how the math, the tokenization, and the diffusion all work together to make this possible. But as we step back, we really have to ask ourselves, if AI can now perfectly capture the authentic conversational vibe, managing 4 distinct voices seamlessly for an hour and a half, how will we tell the difference between a computer and a friend? It's a dramatic shift in human-computer interaction, and it is happening right now. Thank you so much for joining me for this explainer. Keep learning, stay curious, and I'll see you next time.